Hi, my name is Erin McDonnell, and today I'm going to describe an analysis of circadian rhythms. Accelerometers are wearable devices that collect minute-by-minute data on your activity count. And if we dichotomize each minute into periods of activity or rest, then we can study people's daily activity probability profiles. And we can use these curves to learn more about chronotypes, which are phenotypes of circadian rhythm. We propose doing this using curve registration, which is a functional data analysis tool. The idea here is to separate horizontal variability, which is variability in the timing of shared features, from vertical variability, which is the variability in tendency to be active at those shared features of the day. Registration is a two-step iterative approach. So in the first step, we estimate piecewise linear warping functions, which map chronological time into a whole new time domain called registered time. And then in the second step, we estimate subject-specific mean curves using functional principal components analysis. So here's an example of how registration works. In the leftmost panel of the left figure here, we see a bunch of activity probability profiles with one subject highlighted in red. This subject is an early bird, so he happens to wake up earlier than most people. And his warping function reflects that by slowing down time in the morning and speeding up time in the afternoon, so that in registered time on the right here, we see that all subjects have the same general mean curve in their activity probability profile with a 2-peak mean with a midday dip. So here the horizontal variability is removed and all that's left is the vertical variability, which is described in the FPCA results on the right here. Here we have two principal components, one describing overall probability activity and one describing whether the morning peak or the afternoon peak is the more dominant one. And we can use these registration parameters, namely the warping function slopes and the principal component scores, to reveal a whole bunch of different types of chronotype categories. Here we show not only the traditional morning larks and night owls up at the top, but we also propose a few new chronotypes, such as hummingbirds and roosters. And lastly, we compare our registration results to some existing methods for analyzing accelerometer data. For example, in the top here, the daytime interval midpoint in red, which is the midpoint between wake and sleep time, does not map to any single clinically meaningful feature of the day after we register the data. In the figure below that, we see that none of the three parameters of the popular cosinor model correlate with our second principal component, suggesting that this is new information. And finally, if we run FPCA by itself without registration, the resulting principal components conflate horizontal and vertical sources of variability. Thank you, and I look forward to your questions.